Hi everybody in Research Methods, Psych 290. Today we cover section 14 of the reading packet that is about t-testing. Now you might remember that we had a lesson that was over statistical tests in general. This is going to be a little bit more detailed this week, and same with next week about correlation. One of these two is much more relevant to your paper than the other. An independent t-test is when you're trying to see if there is a statistically significant difference between two groups. That's why it's called a between group design. The difference between males and females, dogs and cats, people who are employed versus those who do not have a job, people who have a college education versus those who don't, two separate groups of people. I bet a lot of you are going to do at least one of these for your two hypotheses, if not two. Maybe you're looking at male-female differences and full-time versus part-time college students. Maybe. That would be two independent t-tests. But a dependent t-test is the same group before and after something happens to them. That's called a within-group design. For example, before and after they take a new medicine, before and after they receive counseling, before and after they get tutoring. So it's still a t-test, but it's one group before and after. By the way, dependent t-tests are sometimes called correlated t-tests. I can understand why they call it that, but I don't like that term because it sounds too much like correlation. That's something we're going to be talking about next time. Anyway, moving right along, we're first going to talk about independent t-tests. So, not before and after, but one group versus another group. Is there a statistically significant difference? Why does it say and ANOVAs up here? Well, what if it's more than two groups? Then you're talking about analysis of variance. And again, you might remember that from a prior exam as well. I might not just have males and females, I might have males, females, and those who don't identify with being male or female. I might have black versus white as far as like people's races go, but what about all the other races and ethnicities? I would need other groups for them too. So ANOVA gets more complicated because in this case, you're testing several groups. What if I'm doing freshmen, sophomore, juniors, and seniors in a high school? Well, that would be four groups. That would be a lot of t-tests to do, compare them all to each other, or one ANOVA. So, between groups design, or if it's only two, like male and female, between group design. So, here are some things I want you to know. First, we'll start here. The between groups designs, you don't really need to memorize this, but it does help to get people at random. You want to know whether there is an independent, dependent variable causal effect. If it's an experiment, like giving people medicine, maybe you need a control group, a group that gets nothing. Maybe you don't, depending on what your topic is. External validity, can it really be generalized to other people? Now, a couple of quick things before we move on. It is not important that you have exactly the same numbers in each group. For example, if I made a survey and it's all about people's study habits, it doesn't necessarily matter that I have exactly the same males and females as far as numbers go in my study. If I wanted to know whether people who have a job or people who are not working spend more time playing video games, it's not exactly necessary that I have the same number of working and non-working people. Sure, it would be great if the numbers are close, but it doesn't have to be exactly the same number. Now, here is an important part. Maybe you want to write this down. One thing that you want to be sure is that a person is not in both groups. So for example, I once had a student who did a study on college students. Do you live at home or not live at home? Interestingly, she found that a lot of people say both. Oh, I have an apartment, but my parents are in Phoenix and I stay there a lot. Oh my goodness, what do you do with that person? Are they in the group that lives at home or doesn't live at home? If you ask someone if you're a drinker or a smoker, what if somebody says, oh, a little bit, but not too much? I don't think I would use that person. I want people who identify as one group or another group. You know where this really happens? With race and ethnicity. Do you consider yourself white or black? Well, gee, what if someone is both? What if you consider yourself to be Asian and European as far as ethnicity goes? So, if it's important to you that you have two separate groups of people represented, then you should not use someone who identifies with being in both groups. So, moving right along. You will not need to memorize how this plots out for the exam, but I want you to understand the concepts of it. So let's go through this. Between group designs can be done in the following ways. One, just at random. I'm going to pick people at random. I want men and women. Okay, I'm just going to get random men and women, as random as I can get. That's not an easy thing to do. I'll probably use people that I know, or, people that I work with, or people that I encounter when I'm out shopping. Not totally random, but you try to make it as random as possible. Next topic, stratified. This is a little more complicated. I'm going to put something in the module about this, an example, so hopefully it makes more sense. What if I want my samples to look like the population? At Chandler Gilbert Community College, we are almost 60% female. I think once I read 58%. Well, I might want that represented in my samples too. I might want slightly more females than males in my study. What if you know that you live in a neighborhood where there is a significant amount of high income people? Well, you might want the same percentage represented. Now, years ago at Chandler Gilbert, on campus I'm talking about, not online, we had a discussion about, is 10 minutes between classes long enough for someone to get from one part of campus to another? Well, our campus has grown substantially in the last 20 years, and the answer was no, we need more time. So there became a movement to have 15 minutes between classes, and that's exactly what ended up happening. But we did a study to determine, what about students who say, I have a physical disability or limitation? We have to include them in our study because, well, it might not be as easy for them to get from one building to another, especially if stairs are involved and a substantial distance between the buildings. So, would it make sense to have 50 students with a disability plus 50 students without a disability in the study? Not really. It would make more sense to be stratified. If 5% of students say, yeah, I have a physical disability or limitation, then maybe 5% should be represented in our study. That would make the most sense. I was once on an interviewing committee, and for a person doing research for our college, we have a research department, and we asked this question to try to trick people. What if you got surveys back from students and only 2% of them identified as Native American? And most of the people who interviewed said, oh, well, I would try to collect more. But you know what the correct answer is when you're talking stratified? Well, what percentage of students are Native American? If the answer is 2%, then we got accurate data. But if the answer is much higher than 2%, then yeah, I need to go out and seek more Native American students to fill out my survey. Stratified. The third way of doing research between groups is matched. Matched pair. What does that mean? It might be important for your study to get an equal number in each group. An equal number of high and low income, an equal number of males and females, an equal number of people who work and don't work outside the home. So matching people might be important for your study. You might want equal representation. It all depends on what your study is about. So here we are talking about only one factor, but two groups, male versus female. That's what A is about here. So what about B? I still have one factor, like my survey is about gaming and how often you play video games and which ones you play. But what if I'm not just doing male and female? What if instead I'm doing children under the age of 10, children 10 through 14, children 15 through 17. Wow, can you see where this is going? I'm going to have several groups of people who are gamers. I still have one factor. What is their score on my survey? But now I have multiple groups of people. So do you see how that works? It's B is one factor, but multiple groups. Now, the next one is called a factorial design. This gets even more complicated. Again, you're not going to have to draw pictures for this exam, only describe what it means. A factorial design means there is at least two groups and at least two levels of those groups. So, if I get people, see if I can draw a little picture here, who have major depression, I can put MD, major depression, and then another condition, if you took Psych 266 with me, you already know this, dysthymia, a lower level of depression, dysthymia. Then a medicine is being used, such as Prozac, but some people get 20 milligrams of it. Some people in my study are going to get 40 milligrams of this medicine, and then others get 80 milligrams of the medicine. Do you see how complicated this is getting? So, I give these people the Beck Depression Inventory, and then I'm going to measure their level of depression on this 20-point test after taking medicine for a month. And what I found is, I'm making this up, people with major depression still have a score of 14 on average. That's high. 20 would be the most depression. People who took 40 milligrams, their depression average went down to 9. And people who took 80 milligrams, their depression is 12. How would I interpret that? Maybe 40 is the optimal dose. Maybe 80, you're overdosing on the antidepressant and it makes you feel like a zombie. People do complain of that. What about dysthymia? You're not quite as depressed, but this has been going on for years. 20 milligrams, maybe they have 12 as their level, and 40 milligrams, 11. And 80 milligrams of the medicine, maybe they have 12. Wow, what's going on there? Well, first I want to see if there's main effects, and here's how you do that. The averages. Of people who took 20 milligrams, it looks like their average depression after a month of medicine is 13. Would you agree? People who took 40 milligrams, their average depression is lower, like 10. That's the average. And with 80 milligrams, it looks like their average depression is 12. So here's what you need to know. Is there a main effect for dose? And the answer is yes, for dose. How would you explain it? 40 milligrams resulted in the lowest depression. Does that make sense? Hopefully. Here's another one. Is there a main effect? There's two, by the way. Make sure on the exam you're aware of this. Is there a main effect for the type of depression you have, the disorder that you have? Well, I would do the addition here. 26 plus 9 is 35. So that is, correct me if I'm wrong, 26 divided by 3. Did I say by 5? 26 divided by 3. I don't know what I was thinking right there. My math was totally off, wasn't it? 14 plus 9 plus 12 is 35. So you divide that by 3, and the answer is, after taking a month's worth of this medicine, the average person has, what would it be here, like 11.67, I think? Now I'm doing this in my head. What about dysthymia? Wait a minute, I'm averaging it up. It looks like it is also 35. So the average is 11.67. So here's the question. Is there a main effect for the disorder you have or the type of depression that you have? And the answer is no, because major depression and dysthymia both have an average of 11.67. So that is what I mean by main effects. There is a main effect for the dosage, but not for the level of depression, or also known as the type of disorder. Now, here is how interactions look. You will not need to draw this for the exam. You will only need to explain it. So, if I have the numbers over here, and the possible scores are 0 to 20, and then I have the 3 dosages here, 20, 40, and 80. This is going to take just a second. Then, let's draw a line for each one. If we were in class, I would use pretty colors like blue and green. But here, well, it's red, isn't it? That's what we'll go with. So, let's draw the lines. Major depression, 14, 9, and 12. 14, all the way down to 9. Wow. But then back up to 12. Okay. And then what about dysthymia? It starts lower at 12. It dips slightly down here, doesn't it? But then it meets up at 12. So, is there an interaction? The answer is yes. On the exam, do you want the 1 point and the 2 point answer? The 1 point answer is, my lines cross each other. But the 2 point answer is, these factors interact with each other. Your psychological condition and the amount of medicine you take. The factors interact with each other. Does that make sense? Hopefully. Now we're moving right along. Within group design and the dependent t-test, we're talking about before and after. Why could there also be an ANOVA here, analysis of variance? Because what if you're doing something before, after, and then after again, and then a final test? Like whether people quit smoking. You might want to test them the day the study's over, a week later, a month later, and a year later. Analysis of variance that way is multiple dependent t-tests. Now, 6 things for you to know here in the second and third paragraphs. What is good and what is bad? In college, we're always trying to teach you critical thinking. See both sides of a story, regardless of which one is your opinion. Well, here's another example of that critical thinking. Using one group. What's the good and the bad about it? The good is you reduce variation. What does that mean? I don't have to worry that my groups are varying or different than each other. It reduces it substantially because I only have one group. What if my men were already richer or smarter or not as rich or not as smart than my females, even before my study started? That's a limitation of using 2 groups. Your groups might be different, but you reduce that variation problem by only using one group. Second thing is economical. It saves money, it saves time, it saves stress. When you're only dealing with one group of people, it's a lot easier to manage than if you're dealing with multiple groups, even 2. One group is simpler than 2. And power. Remember the topic we just covered recently about the 0.05 level, and you're trying to get your p-value slightly lower than that, so you do have significance? Well, guess what? The more groups you use, the less number of people in each group, and you could have a type 2 error and not have significance when maybe you should have had significance. So it is much easier to find significance and have power if you only have one group of people. Much more likely to find significance with one group than two. What are the disadvantages to having only one group of people? Well, habituation. In class, I say, what word does this come from? It always seems like somebody screams out the word bitch. No, that's not right. Habit, that's the word. You get into habits. In other words, it gets boring. I'm getting tired of this. I keep doing the same thing over and over again. It's habit forming. People lose interest. They get bored. They get disinterested. They get complacent. Whatever word you want to use. The opposite of that is sensitization. Instead of getting bored by doing the same thing repeatedly, what if they react in a negative way? Like children having to get a shot or a tooth pulled or something. Wow, if you've been through that once as a young child, that might be more than enough for you, huh? So, what could be happening is they get sensitive to it. They don't want to do it because it was a negative experience in the first place. And the third one, order effects. What if you're doing before, after, and after again, and you're using different, what we call independent variables? I give people medicine, I give them counseling, I put them on a special diet. Well, if I'm doing those things one at a time, it's hard to tell which of those factors caused the difference or the change in people. Maybe it was all the factors, or maybe it was just one of them. Sometimes medical studies do that, or psychological studies. It's hard to tell which factor caused the change if you're using more than one independent variable. Now, speaking of that, let's wrap up this chapter here at the bottom. One factor designs. I'm only doing one factor, like giving people medicine. A1, I know it's a steak sauce, but here we're talking about something else. Only one group of people before and after something. So 2 levels of the independent variable, before you took the medicine and then right after. But wait a minute, what if there is multiple levels of that same independent variable? For example, I might put people on 20 milligrams of a medicine, and then a month later, 40 milligrams, and then a month later, 60 milligrams. Kind of like the example we just did, but a little different. So that might make a difference. I don't know. But what I'm doing is still one factor, this medicine, but there are more than 2 levels of it. Multi-factor is the one that I was talking about a minute ago, where the problem could be order effects. Because I guess that could happen in the one we just talked about too, huh? Because what if I'm doing medicine and then next month counseling and the next month a diet? Gee, I am doing before, after, and after again, but I keep changing the treatment. There are multi-factors going on here. This could be a problem with order effects. You don't know which one caused the change in people. You've done so many things to them, but order effects could be on this one too, couldn't it? You keep ramping up the milligrams of the medicine or how many tutoring sessions the kid goes to. It's hard to tell what the effect is in the long run. Did it matter that you kept upping the dosage or the tutoring sessions, or that you kept changing what the treatment is? Maybe or maybe not. But the important thing is that you're using one group of people before and after. Now, last thing on this topic, you can only use people that stick with the study until the end. If you're doing before and after and people drop out of your study, you can't use them, obviously, because you don't have their score before and after. So it's really only limited to the people that will stick with your study and complete it. So here we are at the end of this chapter 14 in the reading packet. There will be a lab over this to practice it, and that's it for now. Thanks.